In this video, we're going to be tackling the LeetCode question, find pivot index. And this question, like many other questions on LeetCode, are best understood with a quick story. If you think back to your high school days, your glory days, you probably had questions like this all of the time. And it goes something like this. You have to travel 28 miles to your favorite store. Let's say your favorite store is Target. Everybody loves Target. But you're not quite there yet. In fact, you've only traveled 8 miles on your way to the store. How many miles are left? And that's basically the whole entire idea behind the pivot index problem. You've traveled 8 miles, and now you need to calculate how many miles are left to travel the rest of the 28 miles. And if you do simple math, the rest of the miles add up to 20 miles. Easy enough. But we're going to apply this concept to an array. Let's go ahead and let's look at the example LeetCode has given to us. LeetCode is going to give us a single array. A single array is the only thing that we need to focus on. And what I'm going to do is I'm going to take this box right here that I've created, and I'm going to block out individual numbers. And I need to block out a number so that the sum of the left is equal to the sum on the right. What exactly does that mean? Well, if I add these numbers and I add these numbers, if I add 1, 7, and 3, it's equal to 11. And if I add 5 and 6, that is also equal to 11, not including the number that we blocked out. And that is the pivot index. This is all great, but how exactly are we going to turn this into an algorithm? In order to create this algorithm, we're going to go back to the car example. In the car example, we can calculate the entire distance. And we're going to do the same exact thing, but with the array. The entire distance, if we add all of these numbers up, is equal to 28. Now that we have the sum, we have the entire distance of every single element in the array, what we're going to do is we're going to begin iterating through every single element. As we are iterating through the array, one by one, we are going to add these numbers to our left sum. We are going to keep track of the left sum. And the only thing that we're going to do is we're just going to add them. So if I travel 3 elements, 1, 7, 3, we're going to get a left sum of, you guessed it, 11. Being that we know the amount on the left side, very similar to the example we had where we're traveling in the store, if we have the left side calculated, we can now calculate the right side. And if I want to calculate the right side, the right sum, the only thing that I have to do is minus the left sum from the total sum, just like the example with the car and traveling to Target. And now that I have the left sum and the right sum, I can determine if these two sums are equal. And each time that we iterate, each time that we go to a different element, we're just going to check if the left sum is equal to the right sum. And that's pretty much the whole entire algorithm. So let's go ahead, let's hop into IntelliJ and let's code it. So we're inside of IntelliJ right now, and the first thing that I'm going to do is create a new Java class. I'm going to call this solution. Within the solution class, we're going to create our method, and this method is going to return an int. And we're going to take in an integer array called nums. So first things first, we're going to need to create some state. We're going to need our total sum, and we're also going to keep track of our left sum. You could keep track of the right sum, but that's going to be really difficult, and it's better just to calculate the right sum on the fly, and I'll show you how to do that here in a second. So we need to add up all of the elements in the array to calculate the total distance, so to speak. Technically we're not calculating distance, but we're going to add up every single element in the array so that we can have all of the numbers and be able to calculate the right sum. So what we're going to do now is we're just going to create your typical run-of-the-mill for loop. We're going to start at the very first element and we're going to iterate to the end. Then what we're going to do is we're going to take our left sum that we calculated, and then we're going to find the right sum. How exactly are we going to do that? Well, AI already kind of knows, but what we're going to do is we're going to minus the left sum, but we also need to minus the element that we are at, the current index that we are at, because we're not taking that current index in the calculation from the left and the right sum. Then we're going to go ahead, we're going to return I. We're going to return the index that we are at. We're not going to return the actual number. We want the index, I. Then after every single time we iterate, if we haven't found the pivot index, what we're going to do is we're going to add the number that we're currently at, the number in the array, and we're going to add it to the left sum. And if we don't find any element that's a pivot index, what we're going to do is we're just going to return -1. Phew, that was pretty easy actually. So let's go ahead, let's get out full screen and let's run our test cases in LeetCode. So I'm going to bring this over and I'm going to go ahead and toss my code into the editor. And let's go ahead, move this over, and I'm going to run my test cases. Test cases passed. Let's go ahead, check our time and space complexity. The time complexity is equal to n, and the memory, the space complexity, is equal to constant. Congratulations, we have passed the interview. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. As always, thank you for watching.